Hi everyone. Today we'll practice using the product, the quotient, and the chain rules. We will focus on examples that require us to use more than one rule. Let's first review what the rules say. If you would like to try the next exercise on your own, download these notes using the link in the video description. The product rule says that if you want to take the derivative of the product of f of x and g of x, you simply take the derivative of the first function, multiply it by the second function, and add to it the first function multiplied by the derivative of the second function. To take the derivative of a quotient of two functions, f of x and g of x, you simply take the derivative of the top function, f prime of x, multiply it by the bottom function, and subtract from it the top function, multiplied by the derivative of the bottom function, everything divided by the bottom function squared. The chain rule says that if you want to take the derivative of the composition of two functions f of g of x, you take the derivative of the inside function and you multiply it by the derivative of the outside function with the inside function plugged in. I have a video about each of those three rules. I will add the links to those videos in the video description. Let's see if we can apply these rules to find derivatives of functions. If you would like to try this problem on your own, stop the video now. We must find derivatives of these three functions, and we are asked not to simplify our answers. We will focus on finding derivatives. In the first example, I have two functions multiplied by each other, and the second function is a composition of two functions. So I will apply the product rule, and while taking the derivative of the second function, I will remember to use the chain rule. So I do f prime of x equals the derivative of the first function. The derivative of the first function is 3x squared. I multiply it by the second function, the derivative just sine of x squared. And I add to it the first function, x to the third plus 1, multiplied by the derivative of the second function. To take the derivative of the second function, I use the chain rule. The derivative of x squared is 2x. The derivative of sine is cosine with the inside function plugged in. In the second example, I also have multiplication of two functions. The first function is a composition of two functions. The second function is also a composition of two functions. So while taking the product rule, I will have to remember to use the chain rule inside of the product rule. And I get f prime of t equals the derivative of the first function. To take the derivative of the first function, I take the derivative of the inside first. That gives me negative 2t. Multiply it by the derivative of the outside. The derivative of e to the x is e to the x. When I plug in the inside function to it, I get e to negative t squared. I multiply this by the second function, tangent of 5t. And I add to it the first function multiplied by the derivative of the second function. I apply the chain rule. The derivative of the inside is 5. The derivative of the outside, the derivative of tangent, is secant squared. So I get times secant squared with the inside function plugged in. In the third example, I have to apply the quotient rule. I have a function divided by a function. While taking the derivative of the top, I will have to use the chain rule. And I get f prime of x equals the derivative of the top, which will require the chain rule, 3x squared times negative sine of x to the third power. This is the derivative of the top. I multiply it by the bottom function, 4ln of x. And I subtract from it the top function, cosine of x to the third power, times the derivative of the bottom function. Using the constant multiple rule gives me 4 times derivative of ln of x, which is 1 over x. Everything gets divided by the bottom function, which is 4 ln of x squared. Let's try one more. I do have a quotient rule again. And I start by saying f prime of r equals the derivative of the first function uses the chain rule. The derivative of sine is cosine of r. The derivative of e to some power is e to that power. The derivative of r squared is 2r. This is the derivative of the top. I must multiply it by the bottom. And I subtract from it the top function multiplied by the derivative of the bottom. The derivative of 3 is 0. The derivative of ln r squared, I take the derivative of r squared and I get 2r. The derivative of ln is 1 over whatever was inside of ln, in this case r squared. Everything gets divided by the denominator squared. So 3 plus ln of r squared squared. I have two monster problems for us. If you know how to do those, you know how to combine the product rule, the quotient rule, and the chain rule. I strongly suggest you give it a try and try to do these two problems yourself. I will do part E now. I will try to make sure to write small so that I can fit everything in one page. I first take the derivative of the numerator because I will apply the quotient rule. I have top function, bottom function. At the top, to take the derivative, I will use the product rule. At the derivative of e to the t is e to the t. I multiply it by the second function, cosine of t. And I add to it the first function, e to the t, multiplied by the derivative of the second function. The derivative of cosine is negative sine of t. This is the derivative of the top. According to the quotient rule, I multiply it by the bottom function, 1 plus 4 sine to the third power of t. I subtract from it the top function, e to the power of t, cosine of t, multiplied by the derivative of the bottom. At the bottom, the derivative of 1 is 0. The derivative of the second expression is, I rewrite the 4 by the constant multiple rule, and then sine to the third power of t is the same thing as sine of t to the third power. So when I take the derivative, I take the derivative of sine, and then I take the derivative of the third power. The derivative of sine is cosine of t. And when I take 3 down, that gives me 3 sine squared of t. All of that must be divided by the denominator squared. So 1 plus 4 sine to the third power of t squared. Time for the biggest example. We must find the derivative. I will use the quotient rule. While using the quotient rule, when I take the derivative of the numerator, at some point I will have to use the triple chain rule. And in the denominator, I have a product of two functions. So when I take the derivative of the denominator, I will have to use the product rule, remembering that inside of the product rule, I will have to use the chain rule. Let's give it a try. I will write very small to make sure I fit everything on the page. F prime of x will be a fraction because I'm going to use the quotient rule. And I get the derivative of the numerator. The derivative of x squared is 2x. The derivative of the second term, I apply the chain rule. The derivative of 2x is 2. The derivative of the middle function, e to the power of x, is e to the power of x, but this time I plug in the inside function to it, so it's e to the power of 2x. Finally, the derivative of secant is secant tangent with the middle and inside function plugged in, so I get secant of e to the power of 2x, tangent of e to the power of 2x. This is the derivative of the top function. I'm supposed to multiply it by the bottom function. So multiply it by 3x to the fourth root of cosine of x squared. Then I subtract from it the top function x squared plus secant e to the power of 2x multiplied by the derivative of the bottom function. And now, to take the derivative of the bottom function, I must apply the product rule. So I take the derivative of the first function, which is 12x to the third power, multiplied by the second function, root of cosine of x squared. Add to it the first function, 3x to the fourth power, multiplied by the derivative of the second function. That is the chain rule. The derivative of x squared is 2x. The derivative of cosine is negative sine of whatever was inside of cosine, so negative sine of x squared. Finally, the derivative of square root is 1/2 whatever was inside of the square root to the power negative 1/2. The quotient rule says to divide everything by the denominator, so 3x squared square root of cosine of x squared, but squared. If you were able to complete this problem on your own, that means that you understand the product rule, the quotient rule, and the chain rule very well.